Hey everyone, today we're going to be talking about 7.2, which is really kind of from chapter 11 in your book. And it's going to just have to do with more about normal distributions and finding probabilities, maybe that aren't necessarily nice values like we use the empirical rule for. But we're going to start with bell work here, where you actually are using the empirical rule. So let's read through this together, and then if you want to pause the video and give it a shot, you can. So the amount of sleep a teenager gets at night is normally distributed with an average of 7 hours and a standard deviation of 1 hour. So they're giving us our mu and our sigma. First, they want us to graph the distribution and to label 1, 2, and 3 standard deviations above and below the mean, and then find some different values. What percentage of teenagers sleep between 5 and 7 hours? How about between 8 and 9, more than 6, or less than 6? So if you want to pause the video right now and give this a shot, you can, and then we'll try it together. Alright, so let's give this a shot. First thing I'm going to do is I'm going to create my distribution. I've got a blank page on the next page here. So I'm just going to make my normal distribution. And it doesn't have to be perfect, something like this. And I'm going to put right in the middle our average, and that's 7 hours. Then we're told the standard deviation, so we're told the average is 7, we're told the standard deviation is 1 hour. So the way I'm going to find that is I'm going to find the inflection point. Remember, that's where the curvature of the graph changes from, looks like we're going downwards here, and then we change to upwards right about there. So it looks like that's about where my standard deviation will be. So that'll be 8, this will be 6, one more out will be 9, and then 10. Very few people will get more than 10 hours of sleep. Here we'll have 5, and then 4. So you can see just kind of a rough sketch is just fine for this. Now let's see what they want to know next. They want to know what percentage of teenagers sleep between 5 and 7 hours. So 5 to 7 is going to be this area right in here. So from our empirical rule, we know that between 5 and 9, so we go 2 standard deviations below and 2 above, that's 95%, and it looks like we want half of that area. So half of 95 is 47.5%, are going to be between 5 and 7. That's all there is to it. Now let's see what else they want. How about more than 6 hours and then less than 6 hours? So more than 6 hours, get rid of our 95% here. So that is starting at 6 and going all the way off to infinity to the right. So to do that, I'll get rid of my area from the last problem here. So I want to know what this is right here, this value between 6 and 7, and then from 6 and out, that's 50%. That's not too hard, right? It's just half of the entire curve, from 7 out, excuse me. So just from 6 to 7, well, 6 to 8 is 68%. So this guy right in here, that is 34%. So 34 plus 50 looks like 84%. That's all there is to it. All right, let's go back one. So now they say, how about less than 6 hours? So for less than 6 hours, let's think if we can be creative about this. So we just found more than 6 hours. It was 84%. So less should be 16%. We can think about it, though. So again, if we think about between 6 and 8, there's 68%. So this is 34% right here. This entire thing from 7 to the left is 50%. And so 50 minus 34, once again, 16. So it works out. Hopefully you've got the empirical rule down now with the homework that we had from yesterday. All right, let's try something new. So 7.2b is called z-scores. We actually have seen z-scores already this year, back in chapter 3, I think it was. But today we're going to actually talk about changing z-scores into finding these areas under density curves, or under specifically normal curves. So let's take a look. So first of all, we define z-score. So you'll want this in your notes. Z-score definition is it's a statistical measurement of a score's relationship or distance to the mean. So the way I think about the z-score is it says how many standard deviations away a certain value is. So for example, we know that so here's our mean. We know 1 standard deviation is at the inflection point, then 2 would be out here somewhere. So like a